Okay, so this will introduce you to the idea of what a logarithmic function is, and it, like you said, it's an inverse of an exponential function. Okay, so the first thing that you learn when you learn about logarithms, you learn about there's two types of forms. So this thing right here is called the exponential form. Now that's what we were just looking at. You have a number to a power that gives you what you call an exponential form. When you have log, that is what we call the logarithmic form. Logarithms have been around for hundreds of years. They were actually sort of invented as a way to make calculations easier before we had calculators. Um, Personal handheld calculators didn't come out until like the 1970s when I was a little kid. 1970, you had this great big calculator that maybe could add, subtract, and divide, and that's all in the world they could do. You go back to the 60s, the 50s, engineers had slide rules. That's how they calculate. Have you guys ever seen a slide rule? Okay, like that's an antique now. Um, and they were based on logarithms. So if you did calculations that were kind of complicated, you got out your slide rule. And even back in the days when the 60s, when we were doing rockets and the early rockets and stuff, engineers used slide rules a lot for all of those complex calculations. So, and logarithms were kind of at the basis of that. So a couple of things that I want to show you how to do is mainly how to convert from one form to another before we really get into what a logarithm is, okay? And then there's a couple of things that you want to know, like if you have log, that's a base 10 log. And then if you have ln, that's what we call a base e log. And your calculator, we'll talk about specifically what that is in a few minutes here, but you have this log button that just does what's called a base 10 log, and ln does a base e log. Any other base has to be done differently, although a TI-84 will do any base. I'll show you how to do that. So if you go down the bottom here, what I want to just sort of train you on right now is all of these things right here are logarithmic equations. You see the log in there, you see the ln, those are all the same. You want to learn how to change this to exponential. So really all you do is you do this. This number right here is the base. That's the base of the logarithm. Whatever the answer is to a logarithm is simply an exponent. So when I'm teaching logarithms, something that you want to get in your mind is the answer to a log is an exponent. Okay, so you would say 10 to the third equals that other number 1,000. And I tried to make these problems come out so that they're true. 10 to the third is 1,000. So we would say the logarithm base 10 of 1,000 is 3. It's the exponent. It's what power you raise 10 to get 1,000. That's what it means. Okay, all right. The next one is like this. If it's ln, I don't know if you caught on. What did I say the base was? E, good. So you rewrite that as log base e, x squared equals 9. Okay, write that like that. Okay. Then the base is e. The exponent is the 9. So you say e to the 9th equals whatever's left over. Okay, so that's a real simple thing that you want to learn how to do, is just how to change a logarithmic form to an exponential form. That'll be super easy for you. Okay, all right. If it's log, then it's base 10. So you have to understand that this is a base 10 log. Okay, so it's worth writing that step down. And then what you do is 10 is the base. Whatever it's equal to is the exponent. So you would say 10 to the z equals whatever's left over, and what's left over is x plus y. Okay, so that's how you change a logarithm to an exponential form. Okay, and after we learn how to do this, then we'll start, learning how to crunch out some logarithms. That'll be the other kind of key thing we'll learn here today. Okay, the next one is natural logarithm. That's ln stands for natural logarithm. So that's really log base e 4 equals x squared. Okay. All right, so tell me how that would go into an exponential form. E to the x squared, okay, just e to the x squared is equal to 4, okay? The little subscript, e is the base. What it's equal to is the exponent, and then that's equal to 4. That's how that goes, okay? All right, you guys okay with that? Okay, all right, you'll learn why we're doing this in just a minute, but you have to start here. Okay, these things right here on example 2, these are all exponential equations. We want to change this to log. So it's just a matter of knowing where the numbers go. So on part A, the base is 2. So you would say log base 2. Make sure you write that 2 as a subscript. Okay, the exponent is what you're equal to. And then 8 is what you're taking the log of. So it's just doing what I just showed you in reverse. Okay. A real easy way to remember this is the exponent is what you're equal to. The base is what's being raised to that power. So that's how that goes. Okay. All right. The next one will go like this. The base is 10. The exponent's 4. So that's equal to 4. So the argument of the log is 10,000. So you could write that way, or the abbreviated way to write this is if you have a base 10, you don't have to write base 10. You can just write log 10,000 equals 4. So if it's a base 10, you can just write log. If it's base e, you can just write ln. So that goes like that. Okay, next one goes like this. You would have log base e, the exponent's b, so that's what you're equal to, and then you're taking the log of a. So you have log base e of a is equal to b, but if it's a log base e, just write it as ln a equals b. You want to learn how to just write the shortcut notation on that when you do that. Okay, next one would go like this. You would say log base a. The exponent is what it's equal, so it's equal to x plus 1 of c. Can't do an abbreviation on that. You just got to write that like that. Okay, so it's a matter of knowing where to put the numbers. Okay, you guys both okay with what I'm doing? Okay, all right. So I'm going to let you just go to the next page and just fill these in. I'll just give you a few minutes to fill this in and see if you can do this okay. There's only really 2 major things you need to learn how to do in this section. One of them is just how to change one form to the other. Okay, now I'll go ahead and run through this. And have you had logarithms before, Juliana, and like in high school or anything? You ever learn anything about that? Think so? Okay, all right, it helps. All right, so let me just go through what you should have had here. So remember, the subscript is the base. What you're equal to is the exponent. So you'd say 3 to the second equals 9. That would be your exponential form. And every problem is the same from here. You would have the base 1/2, which would have to be in parentheses, raised to the negative 3 equals 8. Make sure you have that 1/2 in parentheses, because if it's not in parentheses, it's not technically correct. Okay, log we said was base 10, so we would write this as 10 to the third equals 1,000. That's your answer there. ln we said was base e, so that would be e to the negative 6 is equal to x. Okay, so I think you guys got those okay. I didn't see any problems. Okay, these are totally in reverse, and this would go like this. We would say log base 7, okay, that's what the base is. You're equal to 2, and then 49. Okay, so that one should be written like that. The next one is base 2, so that would be log base 2. That's equal to negative 4, and then 1/16. You don't have to have the 1/16 in parentheses, but it's kind of good to develop that habit. Okay, the next one is log base 10. The answer is the exponent negative 1, 0.1 like that. Okay, now what did I say you do with log base 10? LOG, right. So the best way to write this would be LOG 0.1 equals -1, like that, okay? All right, and then the next one, your base is e, so that would be log base e. Your answer is the exponent, and then you'd have 2x, okay? And how do you write log base e? ln, okay? So the answer I would best answer would be just ln 2x is equal to y, like that, okay? So those are your answers to your problem, okay? So it's just a matter of learning how to rewrite those two things in those individual forms, okay? Any problem with that? Okay, Juliana, you're just here, so I don't know what that. I'm going to do this in a minute, redo it kind of for the next thing we learn anyway. Okay, all right. You want to take a picture on that? You can if you want to, and just get that way. Okay. Then you can get that caught up. Okay. All right. So now the next thing what I want to do, and this will kind of help you learn this too, Juliana, because you're going to have to learn to do what I just did in order to do the rest of the section. There's only two things you learn in this section too, so that'll make it fairly easy. Okay, so what we're going to try to learn how to do here is how to evaluate a logarithm without a calculator. Your calculator, I'll show you how a calculator can do any log. You know, if you've got a TI, you can do any of these, but these are kind of the steps we're going to go through to evaluate a log. And you'll be just kind of setting the expression to x, writing an exponential form, then you try to see if you can do it mentally. Every problem that you're going to do is designed so you can do it mentally. Okay, if you can't do it mentally, then you pretty well got to go to your calculator. Okay, so let me show you how you're going to do this example 3 on the next page then. So you can learn to easily do these in your head, and that's your goal, is every one of these problems to be able to tell me what the answer is in your head very quickly. But here's the technique I'm going to teach you. So go ahead and just write down logarithm base 5 of 125 is equal to x. Okay, our job is to find what x is. Now, what we're going to do is we're going to write this in exponential form. That's what you all just did. So how do you write this in exponential form? 5 to the x power equals 125. Now, it depends on how skilled you are with mental math. Do you know what you would raise 5 to get 125? 3, right, okay, yeah, okay. And you could take 5 to the third on your calculator to make sure if you need to. It's just 5 times 5 is 25, 25 times 5 is 125. So yeah, the answer to that problem is 3. Okay, without a doubt. And see, what you're doing is when you do a logarithm, you're just asking this question: what power of 5 is 125? It's just, what do you raise that base to get 125? The answer is an exponent. All right, so here's how you check. So go ahead and just write down log base 5, 125 equals 3. That's what we figured out in our head. Well, all you got to do is write that in exponential form. So that would be 5 to the third is 125. If you don't know what 5 to the third is in your head, you could certainly take your calculator and prove that it's 125. That's the idea, okay? All right. Next one, do the same thing. Just write down log base 9 of 9 equals x. Now write it in exponential form. So how do you write that in exponential form? There you go. 9 to the x is equal to 9. Okay, you're taking that base to that power. Okay, what's x in your head? 1, good. Okay, so the answer is x equals 1. Told you every problem on here, you'll have the ability to do it in your head. Some of them will get a little bit harder, but that's the idea. So if you want to check your answer, you really can check these things mentally, but all you're really showing to yourself is that 9 to the first is equal to 9. That's how you know. Okay, all right, that's the idea. Okay, next one. Start it off the same way. Write log base 3 of 1 equals x. Okay, how do you write that in exponential form? 3 to the x equals 1. Good. Okay, so what's x? Did you say 0? Good, exactly. Okay, we know that anything to the 0 power is 1. We've talked about that before. Okay, so yeah, that would be that, okay? These things will get a little harder as we go through these. All right, check your answer. Again, you can check it in your head, but what I would like you to write down is, okay, we got the answer 0. The reason it's 0 is because 3 to the 0 is 1. We know that, okay? Are we good so far? Okay, all right. And see, what you want to learn to do as a student is you don't want to have to do this unless you need to. I just think to myself, what do I raise 3 to get 1? I do that in my head. What do I raise 5 to get 125? What do I raise 9 to get 9? That's what a logarithm is. It's another way of writing an exponent. Okay, let's see if we can figure out the next one. So you're going to say log base 10 of square root of 10 is equal to x. Write that in exponential form. So it will be 10 to the x power equals square root of 10. Does anybody know? Told you that'd get a little harder. I'm not sure if anybody would know or not. We have talked about this before, but it's been a long time. Remember that, do you remember what 10 to the 1/2 is? A 1/2 power means the same thing as a square root. Okay, they mean the same thing. So the answer to this problem is 1/2, because anything to the 1/2 power is a square root. Anything to the 1/3 power is a cube root. We talked about that way back at the beginning of the semester, okay? So really this is kind of what you do to check your answer. It's the same idea. This is just something you'd have to have knowledge of. So we just figured out that log base 10 of square root of 10 is 1/2. That's because 10 to the 1/2 is the same thing as square root of 10. Okay, that's just something you need to review on and refresh your memory on. We have talked about that, but it's been a long time. Okay, all right. Go to the next kind of stage here. Like I said, these will get a little bit harder as we go through these. So the next one, we want to write down logarithm base 5 of third root of 25 is equal to x. Okay, and let's see, this one right here is going to be a pretty hard one to do. So you would write this as 5 to the x is equal to third root of 25. All right, now I'm going to give you one more hint on this, and we'll see if you know this or not. Okay, I would go ahead and write 25 as 5 to the second. Okay, I would go ahead and write it like that. All right, now this is something that what you learn how to do is if you have a root, that's really an exponent. The third root of 5 to the second is really 5 to the 2/3 power. They mean the same thing. I think we talked about that briefly back at the beginning of the semester when we were learning about equations. All right, now let me ask you a question, see if you can reason this out. Do you know what x has to be? I mean, they're both 5. They're both 5 to a power. There's only one logical choice that x can be. Any thought? 2/3, right. I guess the only thing it could be. Okay, that's the hardest problem on there right there. And what I did with that is I rearranged the problem so it said 5 to a power equals 5 to a power. So what it really would mean is, like, if I had 5 to the 10th, the only thing that could be is 10, right? If I had like 5 to the 3/5 and I said x, the only thing x could be is 3/5, right? It's the only thing that's even logical in there. Okay, so that's how that goes. Okay, all right. Now we'll check this one on the calculator. I think would be a good way to show you this. So we just showed that log base 5 of the third root of 25 is equal to 2/3. So we need to prove that 5 to the 2/3 is the same thing as the cube root of 25. Okay, so let me just kind of do this on a calculator. You can use a calculator when they get a little bit more tricky to do. So I'm going to take 5 raised to the 2/3, and I'll get decimals on that. I'll get that, 2.92, bunch of repeating decimals, okay? Now I'm going to take the cube root of 25. The cube root I've showed you before on this is under your math button. So if you go math and then down to option 4, that's cube root 25. Oh, crap, put the wrong thing in. Okay, so if I do that, I get exactly the same answer. So I did 5 to the 2/3, I did cube root of 25. That proves they're the same. Okay, all right. And then a little bit later in class, I'll show you how you could do the log base 5 on your calculator. I'll get to that a little bit later. Okay, all right, that's a weird one. That's a little harder. Okay, next one. Now I would write this. If you have a natural logarithm, it's helpful to write that as log base e. ln is the same thing as log base e. ln is an abbreviation. Now we're going to set that equal to x, like this, and then we're going to write this in exponential form. So we're going to say e, when we write that in exponential form, it'll say e to the x equals whatever's left over, e to the 4th. Now this is a whole lot like the last problem, okay? I have e and I have e, that's 4. What does x have to be? There's only one thing that makes any sense. 4, right, okay, it's got to be 4. So the answer to that problem is definitely 4, okay? Now, let me just show you how you can check this on your calculator because you have an ln key. So you can do this if you want to. You can go ln, type the ln like that, and then e is above your division symbol. There's more than one way to get e, but you could go second division raised to the 4th power like that, and what will come out as 4. Okay, so you can tell. But that's the reason why you get 4 is because when we wrote it in exponential form, it's the only thing that makes any sense. Okay, that's how that goes. Okay, let's go to the next one here. So this one, we're going to take the same approach. Log base 2, 1/8 is equal to x. Okay, now write it in exponential form. So in exponential form, that's going to be 2 to the x equals 1/8. Now, I'm just going to throw it at you and see if anybody can figure it out. I don't know if you'll be able to or not. Any idea what you would raise 2 to get 1/8? What'd you say? You're close. You're thinking correctly. Not quite. What is 2 to the 4th is 16. So 2 to the 3rd is 8. So you're thinking right. I can tell you're thinking right. Okay. So here's the idea. It's hard to do this in your head, so let's write 8 as 2 to the 3rd. Write it that way. These problems are designed so the bases can be written the same way. All right, now what happens if I bring 2 to the 3rd up to the numerator? What do I get? 2 to the -3, right, okay. So you could now write this as 2 to the x equals 2 to the -3. Now, the only thing that makes any sense now is that x is equal to -3. That's the only thing that makes any sense. Okay, these get a little bit harder to do, but the idea is if you can't do them in your head, then you try to get it down to a point where the bases are the same, and then the exponents have to be the same. That's the thought process you go through. Okay, now let me show you how you would check this. So we've just figured out logically that log base 2 of 8 is -3. Here's why. Because 2 to the -3 is really equal to 1/2 to the 3rd. We've learned about negative exponents, and we learned that 2 to the 3rd, you know that's 8. That's right. So you were thinking exactly right. You were just thinking 4th power is 16. That's all. But you were thinking exactly the way you needed to. Okay. All right, next problem. This is a log, so what's the base if it's a log? 10, good. So you want to write that as log base 10 of 100,000 is equal to x like that. Okay, so write it in exponential form. So that will be 10 to the x is equal to 100,000. Okay, you just got to do this in your head. What did you have? You have a 4. 10 to the fourth. Here's kind of the way it works. 10 to the first is 10. 10 to the second is 100. 10 to the third is 1,000. We have 5 zeros, so what would it be? 10 to the fifth. Okay, yeah, you're thinking right. Yeah, that's going to be x equals 5. Okay, and again, this is an log, so you can tell you're right on your calculator if you just type log of 100,000, then that'll give you 5. That's it. Okay, that's the idea. So the ones on here that are the hardest are the ones like E and G are pretty tricky for students to learn how to do. The rest of them, you want to get to a point where you can do those pretty easily in your head. Okay, so I'm going to have you go to the last page, and we'll see how many of these we can do. Then I'll give you a little break, and then we got one more section. This is a real short section. Your goal on as many of these problems as possible is to do them in your head. What I want you all to do on your paper, though, is go ahead and start by setting it equal to x, write it in exponential form, then see if you can figure it out in your head. And so see if you understand the checking part on that too. All right, so I'll pause the record. Did fine. I don't see too many issues on that. I think you can just kind of look up here and make sure you got them all right. I didn't see any problem with anything, maybe until you got to part E, like that. Does everybody understand D, why that's a half? Yep. Okay, that's what a square root is. A square root is a 1/2 power, okay? And then this one, E and G, were kind of like this. I wrote this as 5 to the x equals 1 over 25. Then I've designed this problem so 25 is a power of 5. If that said 1 over 36, you couldn't do it unless you had your calculator. But you can, because you can write that as 1 over 5 to the second. And then that really is 5 to the x equals, and you can write this additional step if you need to. You have 5 to the x equals 5 to the negative 2. So x has to be negative 2. Okay. All right. And then this g would be negative 1. You could write that in exponential form like this. 3 to the x equals 1 over 3 to the first. You could write it as 3 to the x equals 3 to the negative 1. And if the bases are the same, then the exponents have to be the same. Okay, so that's how that would work out. Okay, did everybody get those okay? Okay, all right, very good. Okay, let's break here till 1 o'clock, and then we're going to do 6.4, which again is a fairly short section, but we did really well with this. Okay, that'll get you started on logs.